Hello and welcome to this video on adding and subtracting fractions. This is the second video on this topic, so if you haven't already done so, I recommend that you watch the first video on this topic just to make sure you are familiar with the basics. If you think you already know that, then this is the video for you. So a quick recap of what we talked about in the first video. So in the first video we looked at fractions such as this, so 1/5 plus 2/5, and we looked at what that would give us. So let's just have a quick reminder. So if I shade in the equivalent part over here of this circle from here, and then I'm going to colour in these two bits over here, you can see that 1/5 plus 2/5 gives you 3/5. And what we found out in the last video, or what we said the rule was that if you have a common denominator, i.e. the number on the bottom of the fraction is the same, then you can add the numerators. So in this case 1 plus 2 making 3. And that is also true for subtraction as well. If the denominators are the same, so that the number on the bottom is the same number, you can subtract the numerators as well if you have a subtraction. In this video we're going to look at fractions where the denominators, the number on the bottom, are not the same. So let's have a look at example number 2. We've got 1/4 plus 5/12. I just want to have a look at what that looks like using a diagram. So I'm going to shade in 1/4 of this diagram, and I'm going to shade in 5/12. So 1, 2, 3, 4, 5. Okay, so I can see it using a picture. So we want to be able to add fractions where the denominators, the numbers on the bottom, are not the same. So you can see here we've got 4 and we've got a 12. So your aim is to try and get the denominators to be the same, because then we know that our rule applies. If our denominators are the same, we can add the numerators, add or subtract the numerators. So we want to try and make the denominators the same. So you can see here I have got the denominators to be the same down here. They're 12. 12 here and 12 here. So the question now becomes, well, what is 1/4 in terms of twelfths? I'm trying to create an equivalent fraction to 1/4 here, but in terms of twelfths. So you have to ask yourself, how many 4s are in 12? Well, there are 3. So that 4 has been multiplied by 3 to get to 12. And whatever you've done to that 4 there, you must also do to the numerator. So I must also multiply the 1 by 3 as well to get 3/12. And if I just use a little bit of this diagram here, you can see that if I put that over there like that, and then bring it to the front, like so, you can see that we have 3/12. So that 1/4 that we had a moment ago there, you can see is actually 3/12. And that's what we've got here. So we've now got our fraction in terms of twelfths. And over here I've got 5/12. Well, that means because that's the 12 on the bottom and that's 12 on the bottom, I don't need to do anything. I can just keep it as 5/12. So now I've got two fractions that are both over 12, so that means I can add my numerators. And I get, therefore, 3 plus 5 is 8. 8/12. You can simplify that, but I'm just going to keep it as 8/12 for now. Okay, example 3. So here we've got 3/7, take away 1/5. So the denominators are not currently the same. How can we make them the same? Well, we make them the same by finding a number that both of those numbers will go into. The easiest way to do that is to think about the lowest common multiple, which in this case is just going to be 7 multiplied by 5. So 35. You can always just multiply the denominators to give you this number on the bottom. That's a safe bet for making sure that each of these numbers go into it. But if it's a case like the previous example, let me just quickly refer back to that one. Here, I could have done 4 times 12. Here, I could have done 4 times 12 to give me 48. And I could have used 48 on the bottom here. But that would have just resulted in me using higher numbers. So you want to try and find the lowest number that both 4 and 12 go into, which here was 12. So the lowest number here that both 7 and 5 both go into just happens to be 7 multiplied by 5, which is 35. So how many 7s in 35? 5. I've multiplied that side by 5. So therefore I multiply the 3 by 5 to get 15. So 15 35ths, and this side has been multiplied by 7 because 7 times 5 makes 35. So I have to multiply my 1 by 7 to give me 7. And then because I've got a common denominator now of 35, I can just do 15, take away 7, and that leaves me with 8 35ths. And I can't simplify that because 8 and 35 don't have any common factors, so that's as low as it can go. Example number 4, 2/9 plus 3/4. So I want a common denominator. What's the lowest number that both 9 and 4 will go into? Well, it is going to be 9 times 4, which is 36. That's, in this case, the lowest number that both of those things go into. 9 4 is 36. So the 9 has been multiplied by 4, which means the 2 has got to be multiplied by 4 as well, which gives me 8. Here the 4 has been multiplied by 9, so the 3 has to be multiplied by 9 as well. And 3 9s are 27. So now that I've got a common denominator of 36, I can just add my numerators, and that gives me 35 36ths, just under 1 whole. 35 36ths. Example 5, a subtraction. So here I could do 6 times 4 to give me 24 here. I could do that, that's absolutely fine. You'll end up with the same number, but I'm just wanting to make my life a bit easier, so I'm going to get the lowest common multiple. So what's the lowest number that both 6 and 4 go into? The lowest number that they both go into is actually 12. That means that my numbers are just a little bit easier. So how many 6s in 12? 2. That means I multiply my 5 by 2 to get 10. How many 4s in 12? 3. So I multiply my 1 by 3. And 1 times by 3 is 3. Now that I've got a common denominator, I can do 10, take away 3 to leave me with 7. And remember the denominators stay the same, 7/12. Example 6. So again, I could do 10 multiplied by 15 to give me 150 as my denominator, but I really don't want to do that because that's going to give me massive numbers that I want to try and avoid. So what's the lowest common multiple of 10 and 15? Well, it's 30. Both 10 and 15 both go into 30. How many 10s in 30? 3. So I multiply the 7 by 3 to give me 21. 21. How many 15s in 30? There are 2. So I multiply the 2 by 2 to give me 4. And then I've got a common denominator of 30, so I can just add my numerators, and 21 plus 4 is 25. 25 30ths, and I could simplify that, but I'm just going to leave it at that for this example. 25 30ths. Example 7, a subtraction. Here the lowest common multiple is just going to be 10 times by 7 to give me 70. There's nothing lower that both those numbers go into. How many 10s in 70? There are 7. 7 9s are 63. How many 7s in 70? 10. 5 times 10 is 50. And that leaves me with 13 70ths. And that can't possibly be simplified because 13 is prime, and 13 and 70 don't have any other common factors apart from 1. Example 8. Okay, so we now have a mixed number. And that means that we need to change it into an improper fraction to start off with. Okay, so 1 1/4, let's just do a really rough diagram. So 1, that's 1 whole cake, and 1/4 is 1 2 3 4 5 quarters. 5 quarters. And I'm adding 3/5. So step 1 when you've got a mixed number is to change it into an improper fraction like this. Step 2, find a common denominator. The lowest common multiple of 4 and 5 is 20. How many 4s in 20? 5, so therefore I multiply the top by 5 as well, and 5 5s are 25. How many 5s in 20? There are 4, so I multiply the top by 4 and I get 12. So 25 plus 12 gives me 30. Oh, no, 37 20ths. 37 20ths, which is 1 whole and 17 20ths. Example 9, 1 and 5/8 take away 1 and 2/9. So step 1 is to change these into improper fractions, and I really strongly recommend you do this, especially with subtraction, because otherwise it could get a little bit tricky. So I strongly recommend you change them into improper fractions. Remember, if you're changing a mixed number into an improper fraction, the denominator is always going to be the same as what your denominator is there. So the denominator here is going to be 9ths. There are 8/8 in one whole, plus 5 means I've got 13/8. There are 9/9 in one whole, plus 2 is 11/9. Then I have to find a common denominator. The lowest common multiple of 8 and 9 is just the product of those two numbers, which is 72. 9 8 is 72. Then I ask myself, how many 8s in 72? There are 9. So now I have to do 13 times 9. And you might think, oh dear, that sounds a bit tricky. Well, no, because I know that you all have the skills to do a little multiplication like this. So 13 times 9. 3 9s 27. 1 9 is 9, plus 2 is 11. So my numerator there is 117. How many 9s in 72? 8. So you multiply the numerator by 8, which is nice and easy. 11/8 are 88. And if you subtract the numerator, so 117, take away 88, that leaves you with 29/72. 29's prime, and 29 and 72 don't have any other common factors apart from 1, so it can't be simplified anymore. Example number 10, 2 3/4 plus 1 and 4/11. So again, please change them into improper fractions. It just saves you any, it saves you having to remember to add on whole parts at the end. So how many quarters have we got in 2 3/4? We've got 11. How many 11ths in 1 and 4/11? That is 15/11. Then we need to find a common denominator, which in this case will be 44. Times through by 11. So I'm going to get 121 on the numerator there. And 15 times by 4 is 60. So I get on my numerator 181, 44ths. And if you think about it, there will be a bit like there's 2 halves in one whole, there's 3/3 in one whole, there's 4/4 in one whole, there's 5/5 in one whole, there's 44 44ths in one whole. So there will be 88 in 2, and another 44 makes it 132, and then we can get another one in another group of 44, takes you to 176. So we've got 4 whole cakes, 4 wholes, and 5 left over. Because I had 181 44ths, so that's 44, 88, 132, 176, and between 176 and 181 there are 5 left over. Okay, some worded questions now. Charlie eats 2/5 of a chocolate bar and Frankie eats 3/8 of the same bar. What fraction of the bar have they eaten all together? Usually, if that word crops up in a question, it usually means add those fractions. So 2/5 plus 3/8. What do? We find a common denominator, in this case 40. How many 5s in 40? There are 8, so I do 2 8s, which are 16. How many 8s in 40? 5, so I do 3 times 5, which is 15. And added together they make 31/40. Example number 12. A bakery uses 2 3/4 kilograms of flour to make bread and 2 6/7 of a kilogram of flour to make cakes. What is the difference in kilograms between the amount of flour used for bread and cakes? Usually the word difference indicates that it is a subtraction. And it says between the amount of flour used for bread and cakes. Now, you can see here that this is slightly larger, 6/7, so it's going to be 2 6/7. Take away the 2 3/4. I strongly recommend that you change these into improper fractions first, so let's do that. So 7/7 in 1, 14/7 in 2, plus 6, that is 20/7, and I'm subtracting 4/4 in 1, 8/4 in 2, 11/4 there. 11/4, common denominator of 28. That's been multiplied by 4, 7's been multiplied by 4 to get 28, so that top's got to be multiplied by 4 to give you 80. 28 is my denominator, so that has been multiplied by 7. So 11 gets multiplied by 7 to get 77. And if you do that subtraction, 80 take away 77 leaves you with 3/28 left over. Example 13. A school chef has 2 packs of butter. This is quite a typical exam question. They use 4/5 of a pack to make cupcakes and 7/9 of a pack to make pancakes. How much of the 2 packs does the chef have left at the end? Okay, so what I would do is, there are different ways to do this. I have seen students do it in different ways. I'm just going to show you one way now. So add together what they use. So 4/5 plus 7/9. Let's see what they've actually used. Common denominator there, 45. How many 5s in 45? 9. 9 4s are 36. And how many 9s in 45? There are 5. 5 7s 35. So together that makes 71/45. Oops. 71/45. Okay, which is 1 whole and 26/45. So if there's 1 whole and 26/45, how many 45ths are there left to make up to 2 whole packs of butter? Well, all you have to do is count up from 26 up to 45, and you'll find that there are 19 45ths left of those 2 packs of butter. 19 45ths. Okay, here are some questions for you to have a go at yourself. So grab some paper, have a go at these questions, pause the video to have a go at these questions, and restart the video to see the answers. And here are the answers. Well done for having a go at those.